Hi engineering Janta, I am Vaibhav Shukla and today we'll be going ahead with the episode 11 of the WTF series. With this episode the series would come to an end and this series would cease to exist after this. Fine, so basically no new episodes after this. However, we'll move on to different topics and we'll be soon posting up a poll in which we'll be going ahead with what exactly you want from our end. Fine. So if I am visible and audible, go ahead, tell me in the live chat section. Just type a yes if I am visible and audible. If I am audible, type a yes, because today what we are going to cover is actually applications of descriptive statistics in data science. Fine. So today we'll go ahead with this. Great. Good evening everybody. Great to hear that you guys are actually able to hear me. Alongside this, primarily this is the last conclusion class and this is for all those people who were wondering that where we'll be using these methods that we are learning. So I'll start with the first method that I taught you, which is measures of central tendency, right? This was the first thing that we learnt, right? And in this first thing, if I correctly remember, I taught you about mean, I taught you about median, I taught you about mode. Now, how do they help in data science? What role do they exactly play? So, one role is that they give you central values for a distribution which can be used in further modeling. Fine. ये तो हो गई फॉर्मेलिटी वाली बात, ठीक है, कि एक सेंट्रल वैल्यू देता है. But what exactly it offers you when you are a data scientist? So for that, let me tell you one thing. If you're a data scientist, you do one process called as data pre-processing. Fine. In this data pre-processing, you have few steps like data cleaning, data handling missing values, removing outliers. Fine. In all those steps, there is something called as handling missing values. Fine. So for example, you have a data set of 1 lakh plus values. Fine. And in that data set, for one particular column, you have 3 missing values. Fine. And the average, the mean available there is say 50. Fine. For that particular column, say I am saying that the column is age. For that particular column, the average age that is coming out is 50. So for those 3 missing values, you can actually substitute the mean, isn't it? Now all you need to do is you have to figure out whether this whole distribution has some outliers, because if there are outliers, remember this average would immediately shoot up. ऐसा हो सकता है कि the whole distribution is of 20, 25, 20, 25 and then suddenly one age comes 1000, which is a wrong entry, which is not useful, it must be removed, but it can come, isn't it? It can come and it can increase this average. So to handle that, what you can use is median. Fine. Median can also be used. If you still feel that median is not solving the purpose, then what is the most frequent number which is appearing? For example, say 26 is appearing the most in the age. Then you fill that missing value with mode, because mode, if you correctly remember, was the particular tool of statistics where you were getting most frequent outcomes. Is this clear? Is the usage of measures of central tendency clear in data science? If it is clear, just put a yes or no. If it is clear, straight away put a yes. If it is not clear, shoot up with your doubts. If there is no doubt, then we will move ahead. Great. So everything is clear by far. Great. So now let me tell you one more thing. Here you have something called as data summarization. Initially, when you're trying to do EDA, which is exploratory data analysis, at that point of time, these three tools, mean, median, mode, can actually help you give a preliminary summary of the distribution of the data that you are having. That can help you out. Fine. So great. By far is clear, and we would move further to our other measure of dispersion. So in measure of dispersion, what did you have primarily? You had standard deviations. I can see your chats. Great if it's clear. So standard deviation you had, remember? You had something called as variance. You had percentiles, ranges, and if you correctly remember, I taught you about IQRs, which were interquartile ranges. Fine. So you had IQR. I was teaching you the other day about quartiles. So I hope you guys remember that. Now, all these, what do they indicate? They first of all tell you dispersion in the data. Fine. Range and IQR tell you about outliers. Anything that is more than 1.5, anything which is more than 1.5, fine. Rather, I should write it like this. Any value more than 1.5 times of range is outlier. Simply. Fine. Just picking up a basic matrix which is often used. Okay, you're not letting me write outlier fully. I'll write it somewhere else. So it helps you detect outliers. I hope that much is clear. Is that much clear? Go ahead, tell me. Remember this? We had studied about quartiles. We had studied about this graph. We had divided it into quarters like this. This was Q1, this was Q2, this was Q3, and basically this portion was called Q4. If you correctly remember, go ahead, type a yes if you understood this much. Now, I'll go further. I'll talk more about variance. Fine, I'll talk more about variance. So before I proceed with that, if it is clear, good to go. Now, moving ahead to variance. While studying variance, there was one very important thing, which was overfitting and underfitting. Fine. I gave you a brief hint about the same. And at that point of time, I said that I'll explain it in the later lectures. Now it's the time. When variance is very high, what should be there? Guess in the comment section whether it should be underfitting or overfitting. In the chat section, tell me. When variance is very high, should it be overfitting or should it be underfitting? Tell me in the chat section. You have two options primarily, overfitting and underfitting. So when variance is high, you actually feel overfitting. Fine. What is overfitting? Overfitting is a phenomena where you have data at your hand available. You have a training set, you have a testing set. Your model performs well on the training set, but it doesn't perform well on test set. That is overfitting. Fine. So when variance is very high, overfitting happens. When variance is low, when it is very low, stoopingly low, then underfitting happens. But at that point of time, bias must be high. Now what is bias? That's a homework for you. You have to study about it. I can give you a brief hint about bias. Bias is basically the difference between actual output and the predicted output of the model. Fine, great. So it's overfitting. When variance is very high, it's overfitting. When variance is low, which is stoopingly low, then it is underfitting. Fine. So is that clear to all of you? If it's clear, just type a yes in the chat section and then we'll move forward. Now, coming to the example. For example, if there is an e-commerce website, let's take an example of e-commerce website. In this e-commerce website, if you're trying to predict the demand patterns or the demand fluctuations, how do you get them? Variance. Variance allows to predict demand fluctuations. Fine. So all these demand fluctuations can be predicted by variance because it will tell you the distribution of the data and the distribution of products which are being frequently ordered. So you know which would ultimately translate into higher demand. Is that clear to all of you? Is that clear to all of you? Then we would move to something which we lately studied, which was covariance and correlation. I have told a lot about it, but then I'll move to that. I have told maximum about it. Type out a yes if it is clear. Cool. Let's go ahead. So talking about covariance, I have told you about it. First of all, it tells that whether two variables, or not whether exactly, I would say how two variables are actually related. How two variables are actually related and how they vary with each other. Fine. For example, if two variables increase, for example, if x increases and y increases, and then x decreases, then y decreases, in such manner covariance would be very, very positive, right? Now if I go further, this also helps you in feature selection. How? There is a process called as feature engineering. In that there is a step called as feature selection. In that, for example, for model, if you are selecting some features which should be relevant, here if two variables are having high covariance, then it means that they are varying equally with each other, and henceforth one variable can be dropped. So it is used in feature selection. Fine. Now there was one drawback in covariance, that I could not say, if I have four variables and I measure them in pairs, their covariances, I cannot say which has better varying, or which is stronger, which value is stronger. I cannot predict, right? And for that purpose, correlation was actually introduced. Fine. So in correlation, actually, here in this correlation, we figured out, we limited its range from -1 to +1, because the earlier range of covariance was from -infinity to +infinity. Fine. So here we actually stopped that limit, and we got to know how strongly two variables are correlated. Fine. Also it helps us in feature selection again. Why? If an independent variable and target variable are closely related, rather I should use the word strongly related, where the value is very high, then that variable can be an important feature, right? So if any variable is very strongly correlated, I should say correlated, fine. If it is very, very strongly correlated to any target variable, at that point of time, that variable can be considered as very, very important, very, very useful. It is generally selected in feature selection. Fine. Predictive modeling, it definitely helps you out there, and you can actually do analysis of customer behavior. You can check how two variables are correlated, which is more stronger, which should be assigned more priority. Everything can be used. So I hope this much is clear to all of you. If this much is clear, type out a yes in the chat section. If there is any doubt, go ahead, ask me the doubts. Otherwise, we'll wrap today's session. And this is the last session. Henceforth, I'll say one thing. All of you, whatever good you've learned, take it with yourself. Fine. But I am also a human being. मैं भी कुछ खराब चीजें करता हूँगा, मैं भी कुछ गलतियां करता हूँगा, राइट? सो जो मेरे गुण हो वो ले जाना, जो मेरे अवगुण हो वो मुझ में छोड़ देना, ठीक है? Try creating a society where discourses, where discussions are common. Fine. So try doing that. I would always say this. And try creating a society which allows people to keep their opinions on table. Fine. And with that, I'll simply say that if you have any doubts, ask them out simply. Otherwise, I can wrap this session up. So by far, no doubts. Fine. So with that, I'll wrap this session up, and I'll end up again the way I usually do. Keep doing good without any expectation. Good will come back to you in multiplied forms, and it will certainly bring the best results for you from the universe. Fine. So go ahead, keep spreading this knowledge. Wherever you feel this knowledge should be transferred, spread it out. With that, on that note, I leave you guys. Have a wonderful day ahead. Bye-bye. Thank you so much. Thank you so much for such kind comments. Demo channel, thank you. Most welcome.